Alright, number 6, we want to just simplify. So we're going to take the problem that we're given and simplify as much as we can. Looking at this, it looks close to one of those half angle identities. We have S, B, C squared, and then X over 2. That's the angle. And then we got minus 1, and we want to know what that equals. Okay, so the one thing we can do is we can change this in terms of sine or cosine, because the half angle identities that we looked at from the textbook have sine, cosine, and tangent. So none of them in terms of secant, cosecant, and cotangent. So we'll start there. We're going to rewrite this as 1 over cosine. Since it's squared, this will be 2 over 1 over cosine. Cosine squared x over 2 minus 1. Alright, equals. Alright, so if you think about fractions, we can do keep, change, flip. And so that will cause this to be inverted. Cosine over 1. So basically what we get when we do keep, change, flip, we have 2 cosine squared x over 2 minus 1. Alright, now from here, let's see what this looks like. We should be getting closer to something. So, half angle identity. It looks like they've taken this identity here and begin to rewrite it. So if they were to square both sides, that would give us the cosine squared part right here. And then we would have 1 plus cosine x divided by 2. Well, then if we multiply by 2, move that 2 over, we get 2 cosine squared of this, which is what we have. And then it looks like they subtract 1. Move that 1 over. We'll be left with cosine x. So all of this, according to this function, should be equal to cosine x. Looks like they just manipulated this function. So this should be equal to cosine x with a little bit of algebra manipulation. Cosine x. Right, and then number 7, we want to simplify this expression, writing it as a term with only one trig function. Okay, so I'm going to start out with again, probably rewriting these in terms of sine and cosine. 4 minus 2 c s c squared x over this is c s c squared x. Alright, so first I'm going to rewrite these as sine in terms of sine. 4 minus, this 2 will be on top, so this 2, and think about like 1 over sine, and the 2 is going to be on top this time. Sine squared x. And then on the bottom, we have 1 over sine squared x. Alright, so again, the reason why this 2 is on top is the coefficient out front. 1 on top here because 1 was the coefficient out front. So whatever the coefficient out front is being multiplied, which is going to go on top. Alright, so now a little algebra trick. I have a fraction, and I have a fraction on top and a fraction on the bottom. So to get rid of those, to get rid of a fraction, we want to multiply. So we're going to multiply by the common denominator. The common denominator here will be sine squared x, and the same thing in the bottom. So I'm going to multiply top and bottom by sine squared x. A little algebra trick. Sine squared x. And that's going to get rid of the fraction for us. So here I have to distribute sine squared x to both terms. So this will be 4 sine squared x, and then when I multiply times here, it cancels out and just leaves me with a minus 2. Then on the bottom, multiply sine squared cancels out, just gives me 1. So I'm just left with the top part. So 4 sine squared x minus 2. Alright, what I'm going to do is factor out a 2 from both of these terms. So factor out a 2, and that's going to leave me with 2 sine squared x minus 1. Alright, sine squared x minus 1 looks like a Pythagorean identity, so let's see what we can do with this part, if we can rewrite it and simplify it a little bit. So that's minus sign, so that's not quite it. The double angle identity, or close. This looks close if I were to factor out a negative. 1 minus 2. So let's do that. We're going to factor out a negative, and we'll write that as cosine 2 theta. So I'm going to factor out a negative because mine is different. Mine is sine squared minus 1, and this formula shows 1 minus sine squared. So the sign is the negative, and in my problem the sign was positive. So what I'm going to do is I'm going to factor out a negative, pull out a negative. So this will be a negative 2, and then this will become a 1 minus 2 sine squared x. Alright, so this, according to identities, is cosine 2 theta. So I'll have a negative 2 cosine of 2 theta. So this is how we can rewrite that problem in one trig function. Negative 2 cosine 2x. I'm saying 2 theta because that's what we normally use, but 2x. I just changed it myself. 2x. That'd be equal